Lastly, let's take a look at trigonometric substitution case 3. In this example, I'm going to take the antiderivative of 1 over the square root of x squared minus 25 dx. Again, I'm going to change the integral using the correct substitution. Since the integral contains x squared minus a squared, we're going to use x equals a secant theta. So notice it's x squared minus 5 squared. So if we do that, x then would be 5 secant theta. Take the derivative, we get dx is 5 secant theta tangent theta d theta. Substitute in 5 secant theta for x, 5 secant theta tangent theta d theta in for dx, which is what I did here. Now we have to simplify, and hopefully the simplifying becomes a little bit like following your nose through some algebra. Square what's under the radical to get me the 25 secant squared theta. Subtract the 25. Keep everything else the same. Factor out a 25. So I get 25 multiplied by secant squared theta minus 1 in the denominator in the radical. Take the square root of 25. And if I take the square root of 25, that gives me 5. And hopefully we know from what we did before, the 5s will cancel. Now, again, I need to use an identity, and we're going to use the same identity we used in case 1, just rewritten a little bit differently. In case 1, we used the fact that tangent squared x plus 1 is secant squared x. And notice here all I did was brought the 1 to the other side, so I get tangent squared x is secant squared x minus 1. So secant squared theta minus 1 is tangent squared theta. Take the square root. So I have 1 over tangent theta multiplied by secant theta tangent theta d theta. And then, of course, the tangent thetas cancel. And I have secant theta d theta, which probably looks familiar from a problem we did just a little while ago. Integrate that. That's that special integral we talked about. Gives us natural log secant theta plus tangent theta plus c. And again, we draw our right triangle. Remember, our substitution was x equals 5 secant theta. So if I solve for secant theta, I get x over 5. And remember, secant, again, is 1 over cos theta. And remember from SOHCAHTOA, cosine theta is adjacent over hypotenuse. So if I invert and multiply, what I'm going to end up getting is secant theta is hypotenuse over adjacent. So there's the hypotenuse. There's the adjacent. And if I run the Pythagorean theorem, right, I'd get opposite squared plus 5 squared is x squared, and if I did the math out, I get the opposite is the square root of x squared minus 25. You may notice, by the way, in each of these that the third side we find is actually related to what we started with in the original problem. Not always identical, but usually related to. Now I'm going to convert my integral result back to x's. Remember, I had secant. Well, that's easy because that I actually solved for. That I know is x over 5. And then tangent, remember, is opposite over adjacent. And if I do opposite over adjacent, that gives me this part. Again, if I wanted to, I could rewrite the answer. I guess I didn't here. If I wanted to, I could think of it as natural log square root x squared minus 25 plus x. No, it would be all over 5, but remember the rule said we can do minus the natural log of 5 plus c, and then combine those into a single c. And if you looked in the back of the book, that's likely to be what they would do on a problem of this nature.